Very warm welcome to you, and this is basically in continuation to the discussion that we had last time in terms of the formation of the universe itself. And I believe if you remember it quite well, we went ahead of the Big Bang and we reached at the stage of nucleosynthesis. And by nucleosynthesis, I mean the development or the formation of the atomic nuclei, the nucleus of an atom, which you are well aware of the fact that it is comprised of nucleons, which refer to protons and neutrons. And the nucleus is basically surrounded by the electrons that are revolving around the central core. So it varies from element to element, and it's basically the number of the electrons that are basically revolving in addition to the mass of the nucleus that simply turns one element into another. And as I told you, in case of the fusion reaction, it's one of the core processes through one element leads to another. It's the result of the addition of electrons and protons, which simply converts one element into another. So the process, let's say starting from the hydrogen and then changing into helium, in case of these particles, and if they are ionized, they are somewhat unstable, and they would certainly like to simply add up another electron within the orbit of that atom to make it more stable. And this urge, I'll say, of having an electron to neutralize this ionized state is basically the process of transitioning from one element to another. And this is the way we have all the different sorts of elements in our big, gigantic, mysterious universe. So this time, so that I may not miss out any point, I have them here also, and I've just talked about the nucleosynthesis, for which we have quarks and gluon, and it's basically the count and the number of these particles that simply lead towards the formation of a proton or a neutron or the electron. Having said that, the next stage after the formation of these elementary particles was the formation of forces. Now there are three primary forces. We have the electromagnetic force, we have the strong nuclear force, we have the weak nuclear force, and we have the gravity. So nuclear force, and then electromagnetic, and the third one, I hope that you got it quite well. So among all these, my apologies, gravity is considered to be the weakest of all these forces, and it's because of the same reason. If I put my pen down, I can easily pull it up. Yes, the gravity is pulling it down, but even then, it's quite easy for me. I don't have to put so much pressure. Yeah, it can vary from the weight of different elements, but even then, the kind of force that is being applied on this small particle is clearly indicating the fact that gravity is okay, strong, but not as strong as we may consider the nuclear forces, the ones that are keeping all these particles together within a nucleus, or the electromagnetic force, the electromagnetic waves that we receive in the form of light that is coming from the sun. So yeah, it is in various form. It travels in the form of wave, it travels in the form of particle, and because of the same reason, we call light to be a combo or a hybrid of a wave and a particle, because in certain circumstances it acts as a particle, in certain circumstances it acts as a wave. And to study this concept even more, you can just look into or search for, or even GPT, wave particle duality. So having said that, there is another mysterious element in terms of the mass of these small particles that I've just mentioned, like the nucleons. So if I talk about the masses, the mass of these particles is generally like calculated and indicated using the unit of mega electron volt. And do correct me if I'm wrong, but generally it is calculated to be 938 mega electron volts if we talk about the mass of a proton. But if we measure or like theoretically calculate the weight or the mass of the particles, the elementary particles that are basically creating these nucleons. So their mass is very much low compared to the overall mass that is coming through the calculation of these particles. Like the basically there is a big difference in terms of the mass of a proton versus the mass of the individual particles that are basically forming that proton. So as a result, like I was thinking and I thought that maybe I can ask any theoretical physicist when I get the opportunity, that is it the mass of the dark matter that doesn't interact with the light, but still it is interacting somehow or another with reference to formation of the overall mass which is coming within the calculation of that proton. So this is something based on my limited knowledge and command, but still because of the interest that I have, I'm still trying to explore and wonder and ponder and keep thinking to find the right answer. I hope anyone can also respond to this query that is coming in mind, but you'll be aware of the fact that the difference of the mass is there. But I was just wondering, maybe it's the dark matter that is adding up into that weight that simply adds up to create a total sum of 938 MeV, or maybe something else. So this is one thing that I leave to you. I'll keep on searching for it, and once I get the right answer, I'll certainly share it with you also. And then another thing, of course, that really inspired me was the concept of the Higgs field. Like everything around us is basically there within the Higgs field, and it's just the variation within different section or components of this field, and this difference leads to the formation of particles that interact with one another, converting atom into a molecule and an element into a compound. But it's the result of the variation and distortion within the Higgs field that leads to the development of these particles. So that really was something that led towards saying awesome and quite interesting. Then I came across another concept, but for that you need to know that our universe went through, and still I believe is going through, cosmic inflation. It is inflating like a balloon. Whether it started through a big bang or any other concept or phenomena, but still the balloon is inflating. Everything is expanding, getting away from one another, quite evident from the red shift of the light. So the point was that scientists or the theoretical physicists have given a specific term to those particles that are basically accelerating or the cause of this inflation, and they have been called as the inflaton. Many of you may not have heard of it, but this was something new for me and I thought of sharing it with you also. So inflatons are basically those particles that are contributing or are the cause of expanding the universe and ultimately leading towards the cosmic inflation. And as I told you, in terms of the ionized state of these particles, due to which they search for the electron to complete or fill up their empty orbits to stabilize their overall structure, that urge of stabilization led to a state within the universe within which there wasn't any light anymore that was visible, because light is the result of the movement of the photon or the movement of the electrons also. That movement results towards the release of the light, but since everything led towards the stability, that created a lot of darkness everywhere, and we entered into the dark age of the universe, where the only thing that was contributing into the expansion and towards the next stages of the development of the universe was the dark matter. Now, like, this is the kind of matter on one hand called dark, but the reason why it's called dark is that it doesn't interact with light. Everything gets visible when the photons of the light simply hit the particles of that object. And because of the interaction that is taking place, there is the movement of the electrons and movement of the photons towards different direction. and when they fall in our eye, we are able to see the things also. It's because the light that is basically hitting back from the object that we are able to see. So because this hitting phenomenon, we are able to see things. But once this interaction is not happening at the first place, that means nothing will be visible at all. And because of the same reason, since light is unable to interact with the dark matter, despite the fact that it has mass, we are unable to see it. But despite all these vague and cryptic and mysterious, bizarre behavior in terms of interacting with the light, or rather, I'll say, not being able to interact with the light, still it adds up into the mass that is there within the universe. The mass of the dark matter is theoretically calculated to be more than the mass of, I'll say, the light matter or the white matter or the matter that is the visible matter, the one that is able to interact with the light. So overall, based on the calculation, about which I don't know much, but based on those calculations, the mass of the dark matter is more. And because of its dominance, it simply creates those spaces that are basically left up for the white matter to be concentrated, because the rest of the space is occupied by the dark matter. And all those empty spaces are the only spaces that are left for the white matter to accumulate, to come together, and that led to the interaction of these particles, or I'll say we found a stage, or we were about to enter into a phase within which we can see again those fission and fusion reactions that are happening within the star. In other words, that dark matter led to the development of stars, and those star formation at the initial phase was very transient. By transient, I mean quite temporary, because the initial kinds of big bodies of the stars that were undergoing different fission and fusion reactions were very unstable, very huge, very big. And because of that, they always went through the supernova very immediately. By supernova, I mean the big explosion. After, passing through a specific period of time, that short span of life, or I'll even say long, in terms of our lifespan, of course, stars have a very big lifespan. So, in terms of completing that lifespan that a star has, so compared to the stars of this time, those stars were very short in terms of their age and life, and they would explode, and that explosion leads towards the formation of a supernova. Now this supernova simply bangs, or I'll say expand all the particles, all the elements, all the atoms that were formed within that star to the rest of the spaces. And that is how I'll say that we were getting the primary elements that led towards the accumulation and the formation of planets. Of course, it wasn't a very quick process. It took its time, but you can see the connection. The primitive forms of the star expanding, undergoing fission fusion reaction, then exploding, becoming a supernova, spreading all the elements to this entire space, and those particles once again through gravity coming together to form planets. And on the other side, all those particles that spread in the space once again interacted as a result of dark matter to come together, start doing the fission and fusion reaction, forming another star that is more stable compared to the ancestor. And I'm not saying that it's always the single star that is exploding and then forming again, then exploding and forming again. Of course, that is happening. But on the other side, all those particles that are spread as a result of supernova also interact with one another to form planets as well as other stars. So, and this star formation, if I'm not wrong, is also taking place. The birth of the star is taking place in another big thing that is quite colorful, that is quite beautiful, in the form of big colored clouds that we call as the nebula. And you can find some of the nebula even using the telescope, but we'll come to that later. I believe this is quite a big of an information that you can try to digest. I've tried to create all the logical connections that I could, and that has taken me almost 15 minutes. Imagine that. So thank you all, and I'll see you in the next video.